Assalamu alaikum, ma'am. Hope you are fine and healthy. I am Aanand Kumar from BSc 6, and today we are there to demonstrate our compiler construction project, that is the semester project of our subject. And we are total 4 members in our group. My name is Aanand Kumar, and my partners are Navesh Jaramani, Adarsh Vilasai, Pardeep Sukheja. So let's file compile the file of our project. So now it's getting error. Now this is the operator precedence parsers that we have created in our project, and this is the grammar of our parser. For example, s produce e plus e and s produce e into e, and these are all the non-terminals, and here are the terminals from 0 to 9. So let's come to the coding side. These are all the packages that we have imported in our project. For example, this is the IO file package and file not found exception to handling the files. This is the string tokenizer, hash map, and collection. These are all used to for the tokenizers and lexemes. And this is the file writer, IO exception, and file reader. These are all used for filing and input output exceptions. Here is the array list and scanner. Array list is used for the array and scanner for the reading the file. Now let's come to the main class of our project. This is the compiler project. These are all the uh, methods that we have. These are all the parts such as arrays, rules, and to store the grammar. To store the grammar such as past table, non-terminals, terminals, and rules for all the grammar that we have used in our project. Now let's come to the main method. In main method, we have created array for non-terminal. This is SC, this is non-terminal, and this string is storing the string is storing the non-terminals, and here is the all the terminals from 0 to 8. And now let's come to the here we are storing all the grammar, and also we have also printed the grammar. This is the grammar such as e plus e and e into e and 0 to 9. Now furthermore, Navesh will define the tokenizer part. Here we have stored the tokenizer, used it for the tokenizer, and Navesh will define the tokenizer part.
This is Navesh Kumar. So let's begin the tokenization. So as we can see in this file, so for tokenization, before tokenization, we need expression. So uh, in Java, we know that after the end of expression, we must use colon just to tell that the expression is end. But in this project compiler, we set a dollar symbol. So if we 2 plus 5, we don't terminate. So this will cause error. Need of dollar in the last. So this is one type of error if we don't terminate it. So if we press 2 plus 3 uh, divide 5 dollar, so we can see that uh, this cannot recognize. Oh, sorry. So here we are giving 2 plus 5 uh, minus 3 and terminator. Here we given terminator, but their minus is not defined for our language. So it is telling that this is invalid token. So again, compile it. Now again give the expression 2 plus 3 uh, multiply 5 plus 6, and this is dollar. Now we can see it's compiled. So first go to coding side. So here begin the tokenization. First of all, we are looking the tokens in this expression. So as we know that tokens in this expression are literals, uh, which are 2, 3, 5, 6. These are literals, and operators are plus, multiply, plus, and special character are dollar. So these are the tokens in that input expression. Now let's find the lexemes. So lexemes in the expression are 2 plus 3 star 5 star $6. These all are the lexemes. So now checking generating a lexemes which map the following tokens. So here is the code that which make this. So first it take a string uh, from as we map a hash map, we store data in a hash map. So now it is taking from a hash map one by one and checking, is it static or plus, is it dollar symbol or is it integer. So according to that it create a tokens. So after creating token, it generate that token. We can see that their output. So for that, uh, we are this is the set of syntax which we do for to define tokens. So number num comma 2 is for 2, or then plus is for plus lexeme. Num comma 3 is for 3 lexeme. Num comma 5 is for 5 lexeme. Multiply is for multiply lexeme, and this is for the plus lexeme, and this is num comma 6 is for the 6 lexeme, and dollar is for dollar lexeme. So this is the part of tokenization. Now let's come to the symbol table. So after successfully tokenization, what we are do, we store that tokenization which we store on hash map into our file. So further after ending this, we can also see that. So to write a file, we are making object of file, then write on it. For that, we also use trackage, as we know that there may be an exception occur. So for handling exception, we are using trackage. So let's begin the symbol table part. This is the finding of symbols way, and here is the we are displaying this. So as we have only one string, so and data type of input, so its input type data type single, and their scope is local. So after this there comes parsing. So this part Pardeep will demonstrate.
Okay, so now we have lexemes and symbol table, and now we need to check whether the given input is synthetically correct or not. It means whatever the grammar which we have defined, is it meets the input. Okay, so for that it is very important phase, and checking synthetically comparison the given input with the our predefined grammar, which we have to store in our arrays and strings. Here we can see this is our grammar stored in the form of arrays and strings. Okay, here comes the implementation. The implementation is done through some functions which we have declared below, and also we have used some if-else conditions which we can see here, and some loops, and now we need to compare each character with our predefined grammar. Okay, let's come below. Okay, now next, mm, further below. So here we have some functions which generate the parsing table. Okay, here we have some condition based on non-terminals which we need to, okay, here if else conditions which we define whether the given input meets our grammar. Okay, after this there is a success message if the input is meets our grammar, which means the grammar is okay, sorry, which means the wait, display success message if it is correct, otherwise it will generate the error message based on the conditions in the form of terminal and non-terminal Non-terminal will generate the shift, and the terminal will generate the reduce. Okay, this is from my side. Now Navesh will continue further this syntax error or semantics error.
So after completion, it check that if it's a capital, what that means it is non-terminal, and if it expression is small, that means lowercase. That it means it is terminal. So that is for use for lowercase and uppercase. After the completion of it, check it calls syntax error and success function. If if there is syntax occur, then this function will be called and display the parser encounter problem. But if there is success, syntactically it is correct, then it display it calls success function and that displays the parse. Now let's come to the console side. As you can see, it displays string was parsed successfully, and this is the parse table. This is our stack. uh, this side is our stack, this is our inputs, these are actions. So when we give input 2 plus 3, 2 plus 3 is static, 5 plus 6, so it check line by line. So in the last, if we find only dollar, that means it is accept, and it displays string by accept parts. Take this is the way when it accepted. Now let's create a scenario where it is rejected. So here we are giving expression 2 plus 3 multiply 5 and $6. As we know, we give an expression 2 plus 3 steric 5 6 in between, as we have created for single literal. So here in between 5 and 6 there must need a operator plus or steric, but we didn't given. This is while tokenization it is correct, it doesn't generate error, so it perfectly work. But while uh, for the parsing it generate error. The parser encounter a problem while parsing this thing. This is from our side. This is about authors Anand Kumar, Adarsh Walai, Navesh Kumar, Pardeep Sukheja. Now let's come to the rubrics which ma'am tell us that is it we perfectly meet our requirements or not. So first of all, we have to create a tokenization and sample time management. As we can see, this is for the tokenizations and this is for the sample management, sample table. Then there occurs syntax analysis, parse tree, table construction, error and success messages. So here we can see we are displaying error messages as well as in a previous example success messages. And this is the parse table. After that, usability. As we can say, it is friendly, user friendly. Anyone can easily understand and do tasks. Give literals. After the semantic analysis, yes, it is semantic analysis. This is from our side. Uh, that's end. So ma'am kindly consider it. Thank you.